Welcome everybody! In this video we'll solve the problem of battery drain optimization through optimizing FPS in JavaScript and Pixi.js. If you use another engine or make your animations and some actions using requestAnimationFrame, information in this video will be also useful. Disclaimer: if you get a request that the battery is very hot or it drains so quickly by using your application, please firstly pay attention to how many queries you send and receive, because usually the problem is in that. If you try to solve it by optimizing FPS, the battery can drain slowly, but the solution will have no influence on the temperature of your device. The device becomes hot after sending and receiving queries, at least how it was in my case, or there can be another reason, but most likely it won't be connected to the Pixi.js. If you use native requestAnimationFrame, check if you don't implement heavy logic on every frame and don't have more than one requestAnimationFrame in your project working at the same time. So the problem is battery drains quickly. If you have another reason to optimize FPS, you can skip this chapter where I shortly explain why the battery drains. Why is it happening? For working, drawing, queries, other tasks, the browser needs resources. These resources are processors, CPU and GPU for graphics. As a result, more processors work, more battery drains. Why is it happening especially for Pixi.js? Firstly, all elements that we display are in canvas. They are not simple HTML elements, so Pixi.js uses its own mechanism to display Pixi objects in canvas. Secondly, to start work with Pixi.js, we usually create a Pixi application and add its view as canvas to HTML. Pixi application creates not only the view component, but also PIXI.Renderer and PIXI.Ticker. PIXI.Ticker fires on every frame. It uses requestAnimationFrame inside, and each frame it calls a function of rendering to show a current state of the stage. So the PIXI.Renderer is used for displaying the stage. For example, we created a card game on Pixi.js, and if I stop the Pixi.Ticker in the middle of the game, the stage will be freezed, nothing will be changed whatever I do, because ticker doesn't call the stage rendering function. The rendering, displaying everything we need on the stage every frame, needs a lot of resources. By default, with a normal device, the frame fires 60 times per second, and every call of rendering loads the GPU. As a result, battery drains, and more often we render the stage, more battery drains. So the solution is to decrease work of renderer. And how can we do that? The first way is small canvas. Bigger canvas, more pixels need to be rendered. If you can, make it as little as possible. But usually games have to be on full screen, and in my case it didn't work. Second way is amount of displayed objects. More objects we have, more objects have to be redrawn, more work for renderer. Also, usually we can decrease the amount of cards in our game, for example, but if some objects are behind another, set visible false or renderable false to these objects while we don't see them. And the third way is FPS. By default, ticker that calls rendering ticks every frame, and if there are times when no objects are animated on stage, or we can afford worse performance than now in the application, we can call a rendering function less frequently. Artificially decrease the amount of FPS, and the processor will do less work without rendering so many times. How to decrease FPS in Pixi.js? Firstly, define times. Know when anything on stage is not changing, and when we can show worse performance on stage, or when less FPS won't be visible. Another points I'll show you on simple Pixi example, container with rotating bunnies. So the second point is to get Pixi.Ticker. We'll get it through application by ticker property. application has ticker as a property ticker. And the ticker has two properties. They are min FPS and max FPS. They define our current FPS. Min FPS, let's set it to 10, for example. By default, it is 10. And our max FPS, let's set it to 30. Now we don't see that something was changing, but if I'll set to 10 max FPS, let's see that we have really worse performance. It's like lagging. But what if I will want to set it to 0? Let's see what will happen. Nothing will happen. Everything works as usually because max FPS can be 0. So I'll set to 1. And let's see that our stage is really rendering 1 time per second. Good, but we still can have a problem on good devices. 60 times per second is not the upper value of FPS that can be on your device. This value can be bigger. I saw devices with 120 FPS in the browser, but in our case this is more bad than good, because more FPS we have, more work for renderer, more work for GPU, more battery drains. And if you want to be sure that the rendering happens not more than 60 times per second, you can get rid of the PIXI.Ticker and create your own requestAnimationFrame that will control max value of FPS. In this function we will call the stage rendering on every frame and check there the time difference between the current frame and the last frame and cut off unnecessary frames. If there will be extra frames, we won't call the rendering function. If you use or don't use Pixi.js, this example is for you. Let's do it in the same Pixi example. The first thing we need to do is to stop PIXI.Ticker by this method. Let's see if it works. Okay, it worked. Now what we'll do next, we'll create our own function that will render the stage every frame. Let's name it function render stage. Okay, inside this function we will call requestAnimationFrame. requestAnimationFrame, and as a callback we will recursively call our function render stage. Okay, and let's call the function. Okay, I opened the console to just check if we have our render stage working on every frame. And let's just call console log and say hello there. Let's refresh. Yeah, we see that our function is working. You remember that our bunny's container was rotating and how it worked. We had our app ticker and every frame container rotation was changed on some value multiplying on delta. Delta, I guess, is time difference between the current frame and the previous frame to rotate our container equally on each frame. Okay, this function doesn't work because we stopped ticker, and let's just copy it to our function that fires every frame. But we don't have a delta, and let's create it. We'll set it as an argument and we need to get it. I will create a variable of last frame time and the current frame time, and delta would be difference between them. So let's create the variable last time. Okay, last time it would be date now, and also let's do constant current time, and it will be changed on every frame by new value date now. And to get our delta, let's create some constant. I'll call it frame delay. It would be our delta. And let's set it as current time minus last time. And that's all, but don't forget to update last time after our calculation. Last time would be current time. And let's give it as argument here. Okay, so now we got our delta. And let's see if it works. We'll just log it. Okay, refresh. And yeah, it works. It's our time difference between current frame and the last frame, previous frame. Good. What we do next? We have our container rotation, but we still don't see nothing changing. Why is it happening? Because we don't call our application rendering. How we can do that? We will do it by function app_renderer. Let's see if it works. Yeah, it works, but firstly we see that our delta is a little bit not the same as in ticker, but I'll fix it by setting another value to rotation. And here we see that it looks really like in the previous example by ticker. But what do we want? We don't want to render application on every frame. We want to render it according to our, for example, custom variable FPS that we will change in the whole project. And yeah, let's create the variable FPS and set it as 30, for example. What we will do next? We'll check if the current time minus last time when was previous rendering is more than our FPS converted to milliseconds, and it means that if we need rendering, we will do it. If we don't, we will skip rendering on this frame. Let's see how it would be. Current time minus, let's create the variable called last render time. Last render time would be date now. And current time minus last render time. We check if it is bigger than 1000 divided on FPS. Why 1000? Because our second has 1000 milliseconds. Okay, and this means that we need to render the stage, and we just do it. App render, and we need to update our last render time and set it as current time. Okay, let's see if it works. Yeah, we see worse performance. Let's see if 10 would be with more difference. Yeah, we see it like 10. And let's check 1 time per second. Yeah, we have it. But you remember when we at the previous example set max FPS to 0 and it worked as default because our max FPS can be 0, but here we can set 0 and it just won't be rendered. Let's see it. Yeah, it doesn't work, so if you need no rendering, here is a way how to do that without PIXI.Ticker. Okay, so thank you very much for watching. Write in comments where I was wrong. Bye!